Let's get started with the worksheet for Math 335. We're going to go over sections R3, R4, and a little bit of R5. So let's get started. Question 1, we have negative 4xy cubed times 7x squared y. To do this question, I'm looking at the terms in the front, and I need to multiply those first. So it'll be negative 4 times a 7. And then I need to multiply the x times the x squared. And then I need to multiply the y cubed times the y. Now, they have invisible exponents of 1 here for the x and an exponent of 1 for the y. X to the m times x to the n is equal to x to the m plus n, so I'm going to have to add these exponents to each other. We have negative 4 times 7, that's negative 28. X to the first times x squared, that's going to be x cubed. Y cubed times y to the first, I add 3 plus 1 to give me 4. So that's it for the first question. It's not too bad. We just need to remember to add the exponents together when we multiply exponents. Question number 2, we're going to use the foiling method for this question. I'm going to do the first part of it first, and we're going to use foiling. So we'll multiply 2 times 2x, that's 4x squared. 2x times negative 3, that's going to give me negative 6x. And then we'll do the bottom. 3 times 2x, that's 6x. 3 times negative 3, that's negative 9. And that's just the first two products. We're going to write down 4x squared minus 9. Now let's collect like terms. We have the negative 6x and the 6x, they just cancel out. So I have 4x squared minus 9 times 4x squared minus 9. Now we can FOIL this out, and we get 4x squared times 4x squared is, that's equal to 16x to the fourth. 4x squared times negative 9 is negative 36x squared. Negative 4. Negative 9 times 4x squared is negative 36x squared. And we have negative 9 times negative 9 is positive 81. We can collect the two terms in the middle. This gives us 16x to the fourth minus 72 x squared, we don't change the exponents, we're just adding the coefficients here, plus 81. So this is our solution. We FOILed it out twice. You could also use the formula x plus y times x minus y is equal to x squared minus y squared, and you don't have to subtract or cancel out the two terms in the middle. So this could have saved us some time for the left side. And you could have also used the formula x minus y times x minus y is equal to x squared minus 2xy plus y squared. So there's more than one way to do it. You could use the formula to get our solution, or you could just FOIL it out. It's up to you, really. The next question, we're going to practice long division. A lot of students have trouble with long division, so let's go over an example with this. I am going to have to make sure that the divisor is in descending order. So I have x squared. I need an x term, so we'll just put 0x. And then we have a 3. So the power is in descending order. 2, 1, and 0. That's going to be our divisor. And what's going to go inside? Our dividend has to be in descending order as well. So we have x to the fourth. I need a power of 3, and it's missing. So we're going to add 0x cubed. We have a power of 2, 1, 0. So that's okay. So we're going to put 5x squared plus 5x plus 27. Again, we need placeholders for when there's a missing degree or missing power. So we just have 2 in this case, 2 missing powers. Now we could do long division. Let's guess x squared times what gives us really close to x to the 4th. That's going to be x squared. Now we're going to take that x squared and we're going to multiply it to the divisor. X squared times x squared, that's x to the 4th. That's what I want. I want to cancel out this when I do subtraction. X squared times x squared times 0x to the 1st. Well, that's going to give us 0x cubed. X squared times 3 gives us 3x squared. Now we're going to distribute the negative. So be very careful. Don't forget to put parentheses and distribute the negative. So this becomes a negative x to the 4th. This is a negative 0x cubed. This is a negative 3x squared. So let's add this up. This cancels out. This cancels out. I get 2x squared. And of course, I could bring down the 5x. And now I can repeat the process. Let's make a guess again. X squared times what gives us 2x? I'm going to guess a 2. So we'll multiply the 2 times our divisor again. We have 2x squared. 2 times x squared gives me the 2x squared. 2 times 0x gives me 0x. 2 times 3 gives me the 6. Alright, so we distribute. And I made a mistake here. I forgot to bring down the 27, so I'll bring that down now. And then we're going to subtract. So we have 2x squared minus 2x squared. Again, don't forget to distribute. This is actually a negative. This is a negative. And this is also a negative. That cancels out. We get 5x plus 27. Now notice that in the next step we're going to ask x squared times what gives us 5x. Well, the power is less than that of x squared, so we know we can stop here. This is going to be my remainder. So I'm going to take this 5x plus 27, we're just going to add it here, and then put our divisor, which is just x squared plus 3. And this is our solution. Our solution is x squared plus 2 plus 5x plus 27 all over x squared plus 3. This is our remainder, and this is our quotient. If it has 4 terms, the most likely technique to factoring is grouping. So use grouping. Let's try this question out. We have 10ab minus 6b plus 35a minus 21. I'm going to look at the first group and look at the second group. Some people put parentheses. You don't have to, but you can. So we have that the first pair has a 2 in common and a b in common. So we're going to take out a 2b. What's left is, well, we have to think, 2 times what gives us 10? So this has to be a 5. I need to get back the a, so we need to add the a. For the second part, I need something to multiply by that 2 to give us a 6, so this must be a negative 3. And if you're unsure, why don't you distribute and make sure you get the original terms back, and we do have it correct. Now for the second part, I want to decide what to take out. They both share something in common, and that's a 7. So let's pull out a positive 7. Now, there's a reason I'm using a positive 7 is because I want the leftovers to be a 5a minus 3. If this was different than this 5a minus 3, I would be stuck. So I always want to make sure for grouping that these two are the same. Take out 5a minus 3. And what's left is going to be 2b plus 7. And so this is the factored form for our polynomial. Now for this question, before you start doing the AC method, before that, always look for the GCF first. I want to look to see if there's a GCF before the AC method. GCF has higher priority. So let's look. Notice that each term has an x. Each term also contains a 2. Let's take out a 2x to the front and we'll decide what's left over. 2 times what gives us 36? Well, that's got to be 18x. And then I need to make an x cubed, so this has to be squared, because if I multiply 2x times 18x squared, I get that 36x cubed. So I know this is right. And we're going to add 2 times what gives us 18? Well, I need a 9. But we need to get an x squared here, so we'll need to put an x. For the last one, we'll need a negative 2, and that's how you produce 4x. So again, distribute, check your work, make sure it looks good, then we know we factored correctly. Now we're not done yet, because I can factor the 18x squared plus 9x minus 2 again. And for this part, we're going to use the AC method. We multiply the leading term times the last term here. That's negative 36. And then I put the 9 in the bottom. Now you might find it difficult to find these numbers. If you have that situation, well, just multiply numbers that will give you to 36. I always start with 1. 1 times 36 will give me 36. 2 times what will give me 36? That's going to be 18. 3 times 12 gives us 36. 4 times 9 gives us 36. 5 times, well, nothing will work, so we'll skip that. 6 times 6 gives us 36. And that's it. That's the only possibilities that will give us 36. Now, it has to add up to get 9, so there's only one combination that works. 12 and 3. Well, we'll make this a negative 3. That's the only way we'll add up to positive 9. So let's split the middle for my trinomial here. I'm going to write the front as 18x squared, and the middle here, the 9, is going to be split as 12x minus 3x minus 2. Now I can look at the first pair and the second pair and decide what they have in common. So the first pair has a 6x in common, so let's take out a 6x. What's left over is 3x plus 2. Now I need to make sure that when I factor out the second pair, it has to have the same factor, 3x plus 2. So we need to take out a negative 1. That's the only way that we'll have a factor of 3x plus 2. Now look, we know we did it right because these are the same, so I can factor out the 3x plus 2 in the front. What's left over is 6x minus 1. We are finally done with this question. We had to factor it out twice. So use the GCF method if you can. If you can't, try another method. And in this case, we use the AC method next. In this question, I want to simplify and multiply these rational expressions. You have to be good at factoring. So let's factor each of these. I know these are all 3 terms, so we're going to use the X method or the diamond method in all of these cases. Now I don't have to do the AC method, because if you look, the leading coefficient for all of these is 1. So I don't have to split the middle here with the AC method like in the previous example. That's called the AC method because we had a leading coefficient that was not a 1. Here the leading coefficient is a 1, so we're going to use a method called the diamond method. So we're still going to use the same numbers. We have the negative 15 here on the top. Instead of multiplying it by 1, we just put the number at the end. But you could multiply by 1 and still get the same number. We have a 2 on the bottom. That's the b term. And we'll do that for all of these since they use the same technique. We have a negative 24 here and a 2 on the bottom. Here I have a 30 and 11 on the bottom. Here's a 15 and a negative 8 on the bottom. Now you'll have to think, what two numbers multiplies to get negative 15 but add up to 2? Think about it for a moment on all of these and we'll go over the solution. So pause the video and try it on your own. Here I have the number is positive 5 and negative 3. It does give us negative 15 and it does add up to 2. Here I have 6 and 8. This has to be a negative 6 to give us negative 24. And it has to be an 8 to add up to positive 2. For this one on the right, we have 3 and 5. They both have to be negative to get a positive 15 and add up to negative 8. And for the left side here, the bottom left, we have the numbers are 5 and 6. That's how we produce 30 and add up to get 11. So let's try to factor this out. When there's a leading coefficient of 1, that's really nice because you can just write down your solution. You don't have to use the AC method. This becomes x plus 5, x minus 3, and on the bottom we have x plus 5, x plus 6. Really nice. I just need to write down my numbers because the leading coefficient of is 1. We don't have to use the AC method. So let's write down our factors. X minus 6, x plus 8 over x minus 3, x minus 5. Now the fun part, we get to see what reduces. And if you look at it carefully, we do have the x minus 3 reduces with the x minus 3. The x plus 5 reduces with the x plus 5. And that's it. So our solution is just x minus 6, x plus 8. That's what's left on top. And on the bottom I have x plus 6, x minus 5. And that is our solution. So please practice factoring. It's an important skill for these questions. For the last example, we are going to subtract these rational expressions. The number one rule when you are adding or subtracting is we need the same denominator. And that's for adding and subtracting fractions. So I'm going to start by factoring the denominators so I can figure out what my LCD is. So let's do the scratch work here on the side. We'll multiply the 2 times the 5. That gives me negative 10. And we'll put the negative 9 down here. Two numbers that multiplies to get negative 10. Well, that's negative 10 and positive 1. And it does give us negative 9. So I'm going to rewrite this part as 2p squared minus 10p plus 1p minus 5. I can't use the diamond technique because there's a leading coefficient, so we have to use the AC method for this problem. I'll look at the first two and then the second two. Factor out a 2p. What's left is p minus 5, and we'll factor out a 1 here so we get p minus 5. Again, these two have to be the same. If not, I did it wrong. P minus 5 to the front, and we have 2p plus 1 left over. So this is the factorization of the bottom left. We'll do the work again for the right side. We'll multiply this 6 times this negative 2, that's negative 12, and we'll add up to negative 1. Now the two numbers are 3 and 4. This has to be a negative 4. So I'll write this as 6p squared plus 3p minus 4p minus 2. Now, if you were to flip this 3 and the negative 4, you'll still get the same answer. It's just going to be written in a different order. So let's take out the 3p to the front. What's left is 2p plus 1. And here I could take out a negative 2 because I want the 2p plus 1 to be left over. If I take out a positive 2, it won't give me 2p plus 1. So make sure you take out a negative. These two better be the same. Take that out. We have 2p plus 1 times 3p minus 2. So a lot of work, but we factored the denominator. So let's rewrite this equation as the following. This is equal to p over p minus 5 times 2p plus 1 minus 2p over 2p plus 1 times 3p minus 2. Now to figure out our LCD, I want to look at the denominators. They both share 2p, but this side is missing a term on the right side. We're missing 3p minus 2. So I'll multiply by 3p minus 2 on the top and 3p minus 2 on the bottom. On the right, we're missing p minus 5. So let's multiply p minus 5 on the top and on the bottom of the right side. You can see our LCD is all of the terms, and we don't have any repeats. So that is our LCD. P minus 5, 2p plus 1, and 3p minus 2. Now what we're going to do is distribute this p. So this gives me 3p squared minus 2p. And now we have this negative here. I want to treat this 2p like a negative 2p, and we'll distribute that. That's negative 2p squared plus 10p. And then on the bottom, our denominator is just the same. P minus 5, 2p plus 1, and 3p minus 2. Again, the denominator is the same. It might be written in a different order, but it is the same now. So now we can simplify the top. 3p squared and 2p squared gives me p squared minus, now in this case we have negative 2p plus 10p, which is actually plus 8p. And then in our denominator we have p minus 5, 2p plus 1 times 3p minus 2. That is our solution.